Alright, good morning everybody. Today we're going to be working on how to interpret a quadratic graph. First thing we want to review a quick few things on a quadratic function. Your standard form will always be y equals ax squared plus bx plus c. Just know that the c value will always be your y-intercept. Okay, so whatever that value is. Now what we're going to do is we're going to take a look at this graph and we're going to identify some features. One of the features is right here. We have a y-intercept right there. It looks like it's at a 1. We have right here this portion of the graph right there. That's called the vertex of the graph. So I'm going to label it vertex. Okay. Now this vertex is also known as a maximum in the graph. That's a maximum. It looks like Sarah kicked the ball in the air. So it looks like she kicked it around 1 meter high, and then it went all the way up to just over, I'd say, 14 meters, and then the ball went back down and hit the ground right here, close to 3.5 seconds or so. Okay, this is called, by the way, this point right here, this is called the zero of the function. All right, and we're going to estimate it's about, we're going to say it's about 3.5. All right, because it looks like these are all 0.5. That's 0.5, 1. We got 1.5. All right, 2, 2.5. 3, and then 3.5. So our 0 is at 3.5. 0 looks like we got a vertex. Going to say about, I'm just estimating right here, about 1.75, and it gets up to close to just above 14. All right, we'll say 14 for now as an approximate value. Anytime you see like a double squiggly line, that's a approximately, so we're going to say it's about approximately 14 meters high. All right, so all we're going to do is we're going to look at these features. I'm going to draw one more thing in. This right here, we've talked about it before. That's called the axis of symmetry. All right, so that line that splits the parabola perfectly in half is the axis of symmetry. Okay, so there are different features of a graph that you need to know. One of them is right here. That's called the y-intercept. And that is at 0, 1. So if it says, hey, what's your c value? We know that value definitely is at a, looks like it's at a 1. Okay. If it asks us for the vertex, the maximum height, it gets to about 14 meters. And that, what does that 1.75 represent? That represents the time in seconds it took to get there. So at about 1.75 seconds, it got up to 14 meters. All right. So what we're going to do, we're going to look at some statements. We're going to go back to this graph and take a look at those statements. Okay, so we're going to go down here, and it says which of these statements are true. All right, it says Sarah kicked the ball from a height of about 1 meter. That was our y-intercept. Looks like that. I'm going to definitely say that's true because that was our y-intercept. If you look back, there's our y-intercept. Okay. Scroll down a little bit more. It says Sarah kicked the ball from a height of about 14 meters. Well, no. The ball went to a height of about 14, but she didn't start to kick the ball that high. She kicked it about 1 meter. So I'm not gonna select that one. Now it says at its highest point, the ball was about 1.75 meters above the ground. Well, it wasn't the highest point at 1.75 meters. Its highest point was about 14 meters. About 1.75 seconds. That's what we kind of figured out. 1.75 seconds. It got to a height of 14 meters, so not going to choose that guy. Definitely no. At its highest point, the ball was about 14 meters. Yeah, I'd say about its highest point, it was about 14 meters above the ground. So I'm just going to select 2. It says, which of these statements are true? So choose all the answers that apply. So I'm going to choose A and D. Let's see what happens. Hey, got it right. Let's do another one. Okay, let's look at this graph. All right, the function g models the number of mosquitoes in millions of mosquitoes in a certain area as a function of rainfall. All right, so it looks like as it's raining, the millions of mosquitoes are going up to a certain point. All right, and then after that point, they start to go down. Okay, so let's take a look at this graph here. All right, so right now, we're starting with 0 mosquitoes. All right, and 0 rainfall. All right, it gets up to a maximum height. So basically, after 2 centimeters of rainfall, it looks like we get 4 million mosquitoes. Not ideal conditions. All right. All right. So there's our maximum. We got our axis of symmetry right there. We have our 0 right here, and we have another 0 right here. So it looks, If you get too much rainfall, looks like we got 4 centimeters of rainfall. There's just too much rain. It's just going to be, the mosquitoes can't breed and procreate, I guess, if there's just too much. All right, but 2 centimeters is the ideal condition in this particular graph. All right, so that's where we're going to be looking. So it looks like the mosquito population is increasing for anything less than 2, and it's decreasing for anything more than 2. So let's take a look at the answer choices. All right, which of the statements are true? More rainfall relates to more mosquitoes as long as the rainfall is less than 2 centimeters. I would say that's true. More rainfall as it continues to increase in rain. There's more mosquitoes as long as the rainfall is less than 2. So I'm going to say, yeah, that's a good true statement. More rainfall relates to more mosquitoes as long as the rainfall is more than 2 centimeters. Well, that looks like once it gets past 2 centimeters, it starts to decrease. So I'm not going to select B. When there is no rainfall, there are about 1 million mosquitoes. Well, no rainfall is right here. And I'm going to interpret that as a 0, 0. So I'm going to say there's no mosquitoes when there's no rainfall in this graph. When there is no rainfall, there are about 2. No, that's not true either. It looks like that's a 0 and a 0. So I'm only going to select one answer choice and see what happens. Hey, that's right. So basically, that's how you're going to be interpreting the quadratic graph. You're looking at the graph, and once again, let's go over the different parts. We have zeros right here. We've got the maximum. If you go back one more, that's what we call the Y-intercept at 0, 1. So hopefully that'll be enough information for you to be able to get those questions right on interpreting a quadratic graph. Have a good day.